Welcome back to the Aviation RC Noobs Podcast. You found us. My name is Matt.
And I'm Joe.
We're here to be with you in your adventure to RC airborne proficiency. So buckle in, let's take off.
And we're back. Welcome to episode 6, ESCs. Originally, we were going to cover this in the last episode, which was going to be called Motors and ESCs, but last episode was a doozy with motors alone. So, Matthew, how you doing, buddy?
I'm hanging in there. It's been pretty awesome. There's been a lot of crazy stuff going on, and I'm just so happy we got through the motor episode. I know you and I were both, me specifically, was very concerned about it. It turns out that I think we did pretty good. And if any of our listeners have any comments or questions about what were we talking about, or you totally did it wrong, please let us know. We'll talk about it on the air. Get every one of you listeners kind of up to speed on probably the better way, which may not be what we described, but I think it should be close. I think just like this episode that we're going to do today, our goal is to get you a more in-depth knowledge on the whys and the hows of why we use the things we use, what they are. It's easy to have somebody come and say, well, you need a motor, you need an ESC, they got to be sized right. You put them together, put a prop on it and a battery and you're good. And you're like, well, okay. What does all that mean? And they're like, don't worry about it, kid. Just here's the setup and just put it in your plane. You'll be fine. Problem
Right.
is eventually something's going to happen. And maybe you smoke your ESC because you hit the prop on the ground and your throttle was all the way up and it's in a coffin of a plane. There's no air movement or anything. Or it yoinks out and it shorts and it puffs the battery. Or maybe it yoinks off a wire off of the motor. Who knows? Could be a lot of different things. So, yeah. Our goal is to get you to have a solid working knowledge of the whys and the hows of the parts and pieces of the hobby so that when you go out and have fun in your way, that you'll at least kind of understand it better when you're done listening to us.
Okay. Well, I will certainly be relying on you to provide all that information, as ESCs are just not a thing I have a lot of knowledge about, and I only have one, and it does what I needed to do, and I hadn't had to replace it yet.
Right. So okay, this brings up an excellent point. So you are a noob, right? You're a noob to the hobby. You have done some studying only because I've kind of forced you to. In some ways, with this podcast, I think left to your own devices, you'd probably just go, Matt, what do I need to do? Right? I mean, to some degree, and that's pretty normal. But so if your ESC were to go out and let's say you couldn't talk to me, what is it you think an ESC is, and what does it do in simple terms? We can get into the weeds. We're going to get in the weeds.
Mm-hmm.
But I'd love to get your take as a new guy, because I remember kind of what I was thinking, but I remember it being very, very simplistic.
Yeah, and sure, I might still be fairly simplistic. That said, we've talked a good bit, and you've kind of told me a lot of different things about ESCs, and my best friend lives down the neighborhood from me, and we were actually talking a little bit about ESCs because he's building a Caterpillar track small robot, and so
okay, so he's building an RC robot as opposed to like an RC car, more like an RC car, right?
Yeah,
with controls through robotics.
It's, as far as I can tell, and I've not gone over to see it. He's asked me to come over a couple times. I just haven't gone. But as far as I can tell, he's probably controlling it with a controller very similar to us. or at least one very close to it. But I couldn't tell you exactly his structure. But yeah, I don't know. But then I say that, and now I'm thinking about it, he's running brush motor, so he wouldn't have an ESC in that. So scratch that.
You have one. It's just a different one, right?
Oh yeah,
The speed controller controls the voltage in a DC motor, more or
okay,
less, right? It
yeah.
allows the more voltage it goes through a DC motor, the faster it's going to spin.
We were
So,
talking about it a bit on the front end of the project because he was asking me if I had an ESC and a battery and this.
mhm.
Basically, he was asking for everything
Yeah,
but the brushless motor to
nice.
see if he could test some stuff that he had picked up. And I said, yeah, I'm not
Sure.
flying. This was 2-3 months
Breaking
ago.
your
I was like,
bike.
I'm not flying right this second. Like, come and pick it up. Just,
Mm-hmm.
don't burn it and then bring it back. You can borrow it for a few days, but anyway.
Right.
So, like, my understanding of an ESC is simplistic, maybe a little more advanced than somebody just, a few months into the hobby, just because of the conversations we've had. I now know ESC is electric speed control. That it has, or a lot of them have, depending on the size and what you're doing and the application, that's going to have a BEC or battery eliminator circuit in it. I know not all of them have those. Ours fortunately do, because we're running, depending on the battery that we're running, and I know mine being a 3-cell, I'm running upwards of 12, let's see, 4.2 volts. So I'm running 12.6 volts at max
At the
power.
highest, right?
Yeah, at the high range. And then 3.3 on 3 is, so I'm running 9.9. Yeah, on the absolute low
volts.
end. But your receiver and all your servos, or at least servos or receivers we're running, run on 5 volt. So it needs to be stepped down. That's what the BEC does. And I know you're going to get into a lot more of that.
I will, but yeah, maybe the question would be to ask, what would you love to see to make sure we cover today? I know you and I have actually talked about it a little bit ahead of time, but for the listeners, like, what is it that you want to see covered? Because the question you might have, or the hole in your knowledge that you have, is probably very similar to, because most guys, when they're kind of getting into this, you learn about motors poorly pretty quickly. You learn that an ESC is, in fact, a speed controller. You don't quite understand what all the nomenclature is or what the extra wire is for, except that as long as I do it this way, it works. And then if the motor's spinning backwards, then I flip these two and we're good. And honestly, that's all you need to really kind of get it going and get it working and keep it working. But what kind of holes would you like to see filled, I guess, might be the best question.
Well, I know one thing that we've talked about over time, and I don't have a good answer for it yet, is, but I assume you've done the research on, is what do all the beeps mean? Because it does a good bit of beeping when you first fire it up.
It does. And then, makes quite a noise.
Yeah. And then how do I program mine? If I want to program mine, because I could just Google it, but it sounds like you're going to explain perhaps some generic steps on getting into that.
I can. And so I will at least talk about some of the more common ways that I've seen. But take everything, when we get into it, take that caveat, take it with this caveat of look at your speed controller instruction manual, because every manufacturer does it a little differently. It's going to be similar, but unless you've memorized your speed controller manual, go look the thing up. They're all free online. Just look for it. You'll find it. Use that. Or maybe if you're like some of us, we squirrel it away in a deep, dark drawer, never to be seen from again, but we have them there somewhere. So we just go back and look for them. So anyway, so good. So I know I'm definitely going to cover the beeps, definitely going to cover the basics of programming. or even that it can be programmed. I mean, that was kind of news to me when I found out.
Right. Yeah, because certainly I've not had to do mine.
Right.
But I
Have you
wonder
looked
if
for a new? Have you looked
no,
for a new speed controller? No.
no.
Okay. Okay.
I mean, I
So,
guess I've looked at them, but not looking for the purposes of I need a new speed controller.
sure.
Like
Well,
mine's doing what it needs to do.
when you were looking at them, what struck you as what the heck is all that?
Not much. Honestly, I wasn't looking at them that hard. You know, I
Okay.
was
Well,
kind of
okay.
pricing them out at the time to say, okay, if I wanted to get another ESC and another motor, you know, for a second
Hmm.
plane, you know, because I got
Yeah.
multiple receivers. If I wanted
Yep.
to get another plane going, what would I need? Because I got batteries. I don't need, you know, what I need
Yeah.
is motor and ESC at this point. So I was
Exactly. Yep.
pricing a few of them out, but I wasn't digging too deep or too worried about the information there because honestly, I was just, I don't know, I'll grab another one of mine. Or I'll say, hey, Matthew, I want to fly a smaller but much faster plane. What motor do I need and what ESC?
Right. Exactly. Yeah. 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 The answer is big. I'm just kidding.
Absolutely.
Right. Okay. Well, good. Well, okay. So now that I kind of skipped ahead only
Yeah.
because I want to be thinking about those answers while we talk about the things we've done in the last couple weeks, because it's been a couple weeks since we talked about motors. And in that time,
Here's a result from the web.
oh man, I swear Google loves to tell me about things when I start talking.
Mm-hmm.
Sorry. So no, just to kind of figure out what we've been up to. So, do you have any flying stories over the last couple weeks? I know it was Father's Day, so I don't know if you got out with your father-in-law and tried to help him with a Super Cub again or
Yeah,
Simple Cub,
no. So my father-in-law lives.
or did he
I'm in
ask you
this.
not to come by?
No, no.
I'm just
Um,
kidding.
you know, I live in Central South Carolina, like smack dab in the middle of the state, and he
Yeah,
lives on up in North Carolina ways. So
yeah,
generally, it's not a hey, I'm going to swing by on Father's Day and see you. That
right.
said, it'd be a nice thing to do, but with COVID going on, and again, he's still waiting on surgery, so he's in a lot of pain. So
Yeah,
you know,
yeah.
try just
Mobility isn't
yeah,
something that's
we wouldn't be
comfortable.
able to get out and do it anyway.
That's fine.
So no, I've not been out flying. I want to. I'm jonesing
Oh,
hard.
good. Well,
But
that's good. That's a good sign.
what's sort of keeping me from that right this second is my workbench is covered in bedroom stuff
Oh,
because
yeah, that's right. You have a house project.
yeah, we're my wife and I are remodeling the bedroom, and
Ah,
so
yeah.
everything had to come out.
Right, because you guys are doing floor to ceiling too. Like you're not just not just like, oh well, we're gonna redecorate. Like no, you're like scraping ceilings and what else?
Yep. So
You're doing the carpets?
Yep, we're gonna replace the carpet. I'm gonna put
Oh
in
boy.
some maybe not true hardwood, but you know some laminate flooring or something.
Hmm.
We're still deciding exactly what we're going to get in the floor. That's also not $13 a square foot. Because holy moly, you can
It's
spend that much on
easy.
flooring.
Oh yeah, it
Yeah,
is easy.
it's
It
nuts.
is easy.
But yeah, so there was popcorn ceiling in there that's been scraped off. Popcorn ceiling doesn't bother me so long as it hasn't been painted before. If it hasn't been painted, then it's just spray it with some water, let it soak in, take a putty knife and just scrape it off. And
Let's
I
scrape it
gotta
off.
go up there. Yeah, I gotta go up there and do some sheetrock mud work and
Hmm.
fix some holes and fix some areas that some imperfections that the popcorn was covering up. And
Yes,
then
that's what it's for.
and as we were pulling everything out of the bedroom, I knew the bedroom had wallpaper that had been painted over. But once we pulled one of the nightstands, which was up in the corner, then I saw, oh man, the corner of that wallpaper is like peeled back a foot and a half. You didn't see
Oh,
it for the
okay, yeah.
nightstand there. They're like, well, we got to start peeling wallpaper. I went to pull it, and it just, like, that section just wanted to fall on the floor. And I said, oh, this is going to be great. This will be easy. And
Famous last
generally,
words of
yeah,
any renovation project.
generally the
Should be
wallpaper did come off fairly
it
easy.
did. Yeah.
The problem was, got all the wallpaper off, and then one of the walls, like that had the bigger wall. Fortunately, the wallpaper glue on that one was easy enough to remove. Spray some hot soapy water on it, let it soak in, take a putty knife, scrape it off, kind of do that 2 times, and then wash it with soapy water. We gotta go back with regular water to get soap. The problem was the wall that initially had the wallpaper issue. I would have thought, hey, the wallpaper was peeling, therefore glue must be weak. I don't know
Is it
what.
the wall? Was the wall weak?
No, I don't know what kind of glue they used on that wall, or that wallpaper, but buddy, that wall has been whooping me. I've put hot soapy water on it, let it dry, let's let it sit there for a little
Do you have
while,
those?
put more, and to the point
There's a thing called I think it's like a paper tiger, and it's basically like it's like a little palm roller, and it's got a series of razor blades that are on like little swivels, and
mm-hmm,
they wheel, and they all their job is to puncture the wallpaper so you can put
a steamer.
a steamer on there and
Mm-hmm.
hopefully kind of reactivate the glue and soften it so that you can then easily peel it off and then wash the glue residue left over off the walls. Were you trying any of that,
Yeah,
or
so
was it just
I don't have a
the,
steamer, and it's not really it's not something I'm looking to buy.
well?
It's one of those things. If I'll put the time in, and
Oh, I hear you. Yeah.
say some choice words while I'm doing it, but I'll put the time. um, but yeah, the
Yeah.
glue was just that. The glue on that wall was just tough. I mean, I was almost chiseling the glue off, and in the process, of course, marring up the sheetrock a bit, and the paint was flaking off in areas. So I've got a ton of sheetrock mudding to do to smooth that wall out and get it ready for painting. But
Okay. Well,
yeah,
good.
that's what I'm working on.
Does that mean you're almost done so that you can free up your bench? Like maybe next time we'll hear how your simple sore is complete and your simple cub
I'm
is
hoping that by
ready to.
next time we will be able to talk about how I'm nearing completion on Simple Sore.
That'd be good.
Yeah, I think if I can get to a point where I'm getting some good work done in the bedroom, because sort of like peeling wallpaper, scrubbing glue off the wall, sheetrock mudding.
Yeah, that big angry stuff, I
slow.
call it.
Yeah, that's slow progress. It doesn't show a whole lot, so it's kind of hard to
But it makes a
take
difference.
take an evening or two off from that and not do anything but be building a plane and just like there's a room in here to be done. So and Rachel's good. She's patient because I've not been in there every night, but I've been in there plenty of nights, putting in a couple hours here and there getting it ready. So, but no, there's things I want to build. I definitely want to build that Simple Sore and the Cub and some other planes, but my bench is covered. But what have you been building, Matthew?
Probably. Well, I've been flying. Honestly, I've been doing a good bit of flying with family. Not necessarily my family, but my girlfriend's family. Her father was into control line, and we've talked about it before, but he's back into RC, and he's trying to get his grandson interested. And it's just one of those things. Like he's like, I've got time, might as well try it. And matter of fact, he's got this Hobby Zone. What is that one? It's the Hobby Zone Cub. It's like $100. It's maybe 18 inches, something like that. It's got safe technology. I have it here. I'm showing it to Joe because the wing was cracked slightly. But we went out, and I was going to kind of show them a couple things. And we went out to the flying field at the middle school, and it was about a week after all the riots that had happened, and how Fayetteville had some things happen here, and so I wasn't able to fly at the middle school because it was government property, and no one was allowed to be on it at all. So, and I'm like, okay, so if all the county schools are out, where the heck am I supposed to fly? And he's like, you could probably go to the ballpark. So we went to the local ballpark, which isn't entirely ideal because there's a lot of fairly low obstructions.
Hmm.
But I ended up taking about I took about 3 planes out. I took it's not a Sea Otter, Sea Angel. It's a flight test Sea Angel. I have this little biplane. It's like an indoor biplane, but it was low wind, so I took it out. That flew like beautiful. And then I took the simple soar glider. Um, that's been reinforced with a wooden spar in the middle, maybe 8 inches. I'm saying this for Joe's sake. Um, it helps the wing
Thank
from
you.
folding in. Yeah, you're welcome. Um, so we flew that around a little bit, and they all kind of just enjoyed watching what we were doing, and kind of tried to get Debbie's plane kind of up and running, but there was a couple glitches, so I wasn't looking to crash her plane or have her crash it. Not yet, at least. So we just kind of went and did that, and that was a good time. And then the next weekend, I think, was Father's Day, which was great. And that I really couldn't have asked for a better day. Except, the Sea Angel flight that day, the first day, I threw it and it went almost smack face into the ground, and the front wing, like it does, it has all the mass up high, so it just kind of threw it all forward, and I had to spend a little part of the week gluing it back together. So by Father's Day next week, um, it had rained like the Dickens. So I mean, we're talking. You would have thought that we should be building arcs, to protect ourselves. It rained so much, and I've never seen it this bad. But the soccer field that we flew at was ankle deep in water
Yeah.
on the right half. So between the football field and the middle of the soccer field was one giant water pond, and everything was wet too. Like everything was wet. And then that Dollar Tree foam board is not friendly. It does not work well with water at
No.
all. It falls apart. So I was like, oh shoot, that's almost every plane I have in my car. I said, I've got the Sea Angel. I glued it up at the last minute. I was like, let me just do this. So I glued it up, and I took it off from the water real quick and just did a couple laps around. Everybody was there. The whole family was there to kind of celebrate Father's Day with my girlfriend's father, which was great. And they all got to enjoy it. And then we each had like one of these little C-17 or the flight test freighter, essentially the same thing. He had his hobby zone craft, and we were all just kind of puttering around the sky in kind of gentle loops over the football field. And they're all like the EPP foam, so they're less affected by water, right? So getting
Right.
a wet landing isn't a huge deal. As long as we're not dumping it into the lake, we're good. So everything was good, and we just had a pretty easygoing, enjoyable day. Um, I took the Sea Angel out one last time, and of course that's always the curse. And I guess when I landed it, when I hit the land as I was taxiing around, I had gotten some speed to try to get up, and it kind of stopped. It caught the pontoon and pulled it. So when I started to taxi it around the water to get speed again, it kept dragging into the water, pulling the pontoon down, pulling the wingtip down into the water, and started basically doing a series of loops in the water. And I'm like, shoot, I don't think I'm going to be able to get this thing off the. So I slowly taxied it. It must have been like, I don't know, about 5 feet a minute. It was real slow, and it's
You
just
could
like
have
put
just
put
walked
put
out
put
there to
put.
get it.
Well, I ended up having to, because as I got close, I kind of gunned it a little bit to give it a little bit of, maybe get back up onto the land a little bit. And
Hmm.
it hit the land. And of course, it's still a ways out because it's shallow. And it just sort of nosed over and just, boom, and the motor's half in the water. And I'm like, I guess I better just go get it. So I took off my shoes and socks and walked out there and grabbed it. So it's kind of in that state of, I'll get to it when I get to it. I'll have to repair the pontoon. The barbecue skewer is sticking straight through the wing. Yeah, I mean, it
Oh
definitely
boy.
got it got some damage, but that's okay. It's worth repairing. It's a fun plane to fly. I just got the 9-inch motors that belong on it. So for those who build it, if you're listening and you're looking to build that Sea Angel, It works great on a 10-inch motor or a 10-inch prop. The 8-inch prop is just not enough oomph. And it basically is just flying just past stall speed. So, which means when you slow down a little bit, it's going to tip stall the wing really hard. Um, on the 10-inch, it's awesome. However, the 10-inch is almost clipping. We're looking at maybe you put a barbecue skewer in between the propeller and the surface of the pontoon on the front, like the nose of the plane. That's all you got. So when you land, the motor starts eating away at that front nose cone piece.
Hmm.
So 10-inch motor is our 10-inch prop isn't the best. It's great for flying, but it's not the best for keeping your plane in one piece. So they recommend a 9-inch. If you can get the 9-inch, you'll be happy for it. It's a great plane. I've enjoyed it every time I've flown it. Even when I crash it horribly into the water. And then, we went out to the flying field, and I brought out the FT Arrow, which is I think it's 18-inch or 20-inch flying wing, 22-inch flying wing. And I've got it set up. There's a skin that somebody put together to make it look like the Thunderbirds.
Oh, nice.
Thunder Angels. Yeah, it's awesome. It's beautiful. Great looking thing. And it flew like a dream. It flew exactly. It was fast. I was doing low passes, and people in the back going, "Come on, lower." And you're like, I don't think I can get much lower without it tanking. Come on, lower. You're like, yeah, okay. But we're doing that, and there's people flying their stuff around. So there was a turbine jet. So that was going at 150 miles an hour or faster.
Oh yeah.
Or whatever the legal speed limit is. So maybe only 100 miles an hour. But I don't know. The thing was cruising. There was a helicopter. A guy flying his helicopter while I was flying. I can't remember what I was flying. I think it was just flying a simple soar. And I was just flying that around. And he was flying his helicopter around, which is great. And of course, we're both the middle of the field is a pond because it's the same day that all that stuff was happening at the other field.
Mhm.
And so we're all flying at either edge of the field, either end. So we're just kind of hanging there, and he's got his helicopter like right in front of me, which I'm sitting there like, boy, I hope he knows what he's doing with a helicopter. So I'm looking at my plane, But I'm familiar with him. I knew he knew his aircraft. I think he's actually a helicopter pilot in his spare time, or at least he was in the military, and he just does this for fun. I'm trying to think. So we flew those couple things. There's a helicopter. There's a jet. There's a biplane. There's like every kind of plane you could find. And there was a warbird that was cruising around. It was maybe a 10th scale, maybe 8th scale, something like that. It was pretty good size. It was like a 6-footer wingspan. So I guess what is that? It was nice. Really enjoyable day. It was great weather, with the exception of the water. And there was a lot of people for that kind of day. It was a lot of people out at the field. It was a good time. I followed it up the following day, brought out the same 2 planes thinking this is going to be great. And it was just one of those days that was trying to tell me, don't go fly, buddy. Just don't do it. It'll be okay. Just let it be. And of course, I don't ever listen to those days. Just one of those things, like certain things weren't quite lining up. They weren't quite off enough where I'm like, oh, I can't fly it. I was like, but I tanked it into the ground a couple times. I was trying to fly the wing FPV. So I was trying to get it up into the air and just fly it long enough and level it out so that I could just put the FPV goggles on and fly around a while and just have a great old time. Needless to say, something was off, and I kept basically not having level flight. So I would try to put the goggles on, and by that point, the thing's going nose down, and I take the goggles off, and it's just in time for it to see it smash into the ground. It's like, crap. Managed to find all the pieces, a bunch of hot glue and some surgery, and it'll be up and running again. The skin didn't get damaged too bad, so I should be able to cut it away and peel it back, fix the substrate, the base material, and then kind of re-glue that skin back down, and then it should look like brand new, and it will probably fly just good too. So, yeah, it was just one of those days. It was great Father's Day, followed up by a maybe you shouldn't have flown. I flew I flew the Simple Soar after that, and it was a good time, but it was, I guess, kind of was tainted by the arrow tanking into the ground
Yeah.
hard. I mean, hard. I mean, it was probably about 3 inches into the dirt, the nose.
Oh man.
Yeah, and it's just terrible. Anyway, but it was fun. I look back on it, and it was a good time. So, and then I've been basically, for the most part, I've been working primarily on my Viking S3 build.
Mhm.
It's kind of a master series with, it looks very, I'll call it realistic compared to boxy. Um, and it's looking really good. I just put the landing gear, the back landing gear on it, and I've worked out how I want to do the front landing gear. I just have to cut out some plastic pieces. It's some, I'll call it track work. So there's a
Okay.
bunch of like guides that I need to have the push rods that they have to follow the guide path. And so I'm not skilled at doing that. Like I'm not a machinist, and I'm not really sure the best way to do it or what the best tool is. I have a Dremel. I'm going to use that and hope it works. But um, I don't know. Maybe I'll just drill and I'll use my scroll saw. We'll see. I'll figure it out and then I'll let you guys know. And I designed an FT Easy version of the Viking. So I've got the cutouts right here to be able to put on some foam board. I'm showing Joe.
Okay.
So I've got the individual pieces. So when I feel like sitting down to a movie and not building, I'll probably bring a piece of foam and start tracing it out and just kind of fiddling with that stuff. The other stuff is kind of in limbo for now. The 90 millimeter jet I've got mostly built, and the Synergy that I have cut out. So they're there, and they're definitely on the table. They're just not being worked terribly hard. So I want to see the Viking S3 in the air. I'm really excited. It's coming along really nice.
I need to go up and see you sometime. Just see all these planes in person, because it's
Yeah,
been a while
man.
since I've seen your collection.
Oh, yeah, collection of broken planes. I keep flying them and trying to do some interesting things with them, or flying them when I shouldn't, and then I end up breaking them a little bit. But
Yeah, but you
I
enjoy the building and repair part.
oh heck yeah, yeah. And I'm learning more and more. I think I'm coming close to the edge. I keep watching Mike Patey, and he's the guy who built the Draco, which is like a Super Cub.
Hmm.
And he's building this plane called Scrappy. He literally is taking the scraps from other planes that either he or his friends have had, and he's kind of making a Frankenstein plane out of it. And by Frankenstein, I mean one of the nicest looking carbon fiber wrapped beauties that you could come up with. I mean, you could tell it's going to be amazing when he's done, because I don't think he knows how to do anything else. But anyway, I've been watching a lot of that stuff, and I keep looking at that, going like, maybe it's time to start fiberglassing, because that's not a whole lot different. I mean, it's epoxy. Put the fiberglass down, you let it soak into the stuff. You put I'll call it a bleed cloth to kind of pull it through and create like a surface, and then you do a finish coat,
Hmm.
and you've now got something that's sturdier, stronger. It's got a glassy finish when you're done, and it's one of those things. The more I watch him do that, I'm like, man, I should try that, because that's got to be awesome. Um, well, so you've been working on your bedroom,
Hmm.
and your workbench has pretty much been occupied by that kind of stuff, but it's going to get cleared off probably sooner than later. So tell us
Ideally.
what you want to work on.
I want to finish building this Simple Soar,
Yeah. Did
because
you start it all other than the plans?
yes.
I mean, that's a big step. I mean, that's a big
Yeah.
step, is to get the
I mean,
plans ready.
yeah. Honestly, I spend probably a quarter of the time, the total build time cutting the paper out.
Right. Because
Just
you're
just because of the
using
way,
them as patterns, right?
right? Just because of the way that I do it. So I've had a few pieces cut out, and it was just that the the main wing section when I went to fold it over, and I didn't do a 45 cut on it to
Yeah.
relieve the stress, and it popped that
Mhm.
paper, and that's sort of where that got left off.
Do you
And
remember the
then
solution? One of the solutions to that?
I would put those 45 cuts in it.
Well, one is of putting the 45 cuts, but if you're going to do something like that, that you know you're looking to compress the foam, because when you compress, maybe you take off the paper on the back but leave the full depth of foam. When you fold it, it's going to create a different rounded edge than a
Mm-hmm.
45 than if you took out the paper, right? Those are going to have different looks when you round it over. But you're right, it's going to be potentially brittle, right? That's going to be a weak point. So you take the other side before you kind of gouge out or do whatever you're going to do to the backside, put tape across that seam so that when you pull, it's got the tensile strength of the tape.
I might have to do that.
And then when you get into shape, you still do it, somewhat gentle and persistent. But
Mm-hmm.
when you fold it over, it'll have that extra strength. You don't have to worry. And honestly, even if you did pop it, what you do is you go back and tape it, and then you put the hot glue. The hot glue kind of allows you put it in the seam too, and then it also allows some of that foam to kind of melt in the heat
Mm-hmm.
and soften. And then when you roll it over, it gets the right form that you're hoping for.
Okay.
Sometimes I forget that putting glue in that joint actually makes a difference in how it forms. It's not necessarily just structural. It's not to adhere the two pieces together. It's almost as much to allow it to form simply. So you
Mm-hmm.
put the glue in and you start folding it over, and that heat in the glue helps soften and dissolve some of that foam, and
Okay.
it gives you the shape you're looking for. So anyway, that's
Yeah.
from trying a bunch of different options. Okay, so you got the simple sword. That's on your plate, which
Yep.
I cannot. That is my go-to plane all the time. Just
Yeah, I've
having
heard you reference it plenty.
a gliding having a gliding plane in the back of your car, or easy access to get to. It's just a great way to end a day that might have been rough. You can't just anyway. So okay, so you're gonna do simple soar.
Mm-hmm. Still want to build the simple cub to see if I can work out the issues I encountered when I was building with my father-in-law, and
Mm-hmm.
then if once those two are done, which that's a good bit of building for me. But once those two are done, I do want to eventually build the Spitfire for a faster, fancier flying plane.
Mm-hmm.
But I'll either do the Spitfire, or having had success, hopefully, with a simple soar, revisit my original glider
That would
and
be awesome.
get that one built properly, and
It
not have
was
it
built
be tail
properly.
heavy.
It was built properly. You just weren't patient enough to balance.
I know.
That's okay. No, I'm excited that you're going to go back and get that built.
All right. It
Awesome.
looks like you've got a clarification section here, so talk to me about that.
I do. It says copper pipe and magnet, and
I'm assuming that's in reference to eddy currents from the last episode.
yeah, I think it's when you talk about like when you drop a magnet down a copper pipe, the movement of the magnetic field through the conductive material copper moves electrons and thereby generates almost an anti-current, if I recall right.
Mm-hmm.
And it ends up slowing. It creates a reverse magnetic field, which ends up either slowing by repulsing the magnet, or it ends up basically pulling the motor on the back, or pulling the magnet on the backside. And I can't remember what our I wish I could remember what the clarification was, though. I have it because 2 weeks ago,
When you were typing these notes,
4 weeks ago, when we were typing up the motor notes, I think this was part of it. But I'm trying to remember if it was the right hand rule versus the left hand rule, or what. I think it was. it was more for me to go through and explain the technical piece behind that, but shoot.
Yeah, it's been a while,
It's been
so
too long. It's been too long. I've been trying very hard not to remember the motors episode. It's so dangerous. But yeah, I think it's just that look, if you're curious about how that works, look it up. There are a bunch of videos on YouTube that explain how that functions and how interesting that phenomenon is, because it is different than you'd expect.
hmm
And it's some pretty cool science going on there. So check it out, because it's the same kind of things that happen within your magnetic coil in your rotors.
all right. Tell me about ESCs.
Do I have to? I'm just kidding. Um,
This was your idea.
yeah, no, it's uh, yeah, I think it's just a good idea for any beginner going into the hobby to understand the components that they're using to achieve the goals they're looking for, right? Um, we're not in this hobby to build an ESC or understand motors. That's not primarily why we're in it. Maybe some of us, but most of us are in this hobby because we want to achieve a certain goal or a mission, maybe, or we have like, oh man, I saw this guy flying this plane. I want to build a plane like that. I will never be a pilot, but if I make an RC model, I can feel like I'm flying it too, right? Or
hmm
whatever your reason or your goal is, or whatever it is. So these components are a means to an end. But if you have a specific goal in mind, you need to understand how these components work together to be able to achieve those goals. Also, if you have a system that you bought, let's say I bought a Hobby Zone product like the Scout or something. It comes with the motor and ESC and all the servos and all that stuff, all in the box. Most of it's all together and it's fantastic. And I'm flying it and it's going great. And I dumb thumb it and tank it into the ground. Now, the something happens, I don't know what, and my ESC shorts out, right? I see the magic smoke come out. It stinks like electric fire, which means the component has been overloaded. And now my ESC isn't pushing my motor around, which, what the hell? You know, that's not okay. But now I got to replace it. You think, now you got to think, well, what went wrong, right? Why did the ESC fail? Because these components are designed and paired together typically perfectly to be the optimum choice. So, what are the things that could have failed? One of the things ESCs do is they convert electricity and they change the voltage. And anytime you change voltage, the byproduct is the excess energy has to go somewhere, right? So, you're
hmm
essentially transforming it. And by doing so, when you change the voltage, you give off heat. And certain ways give off more heat than others, but either way, a speed controller takes electricity from a battery and pushes it to the motor. It also converts some of that down to 5 volts if you have a BEC, which is a battery eliminator circuit, and then you push that to the receiver. Well, that BEC is generating heat, and anytime the electricity is flowing through the speed controller and converting it to sinusoidal waves that push the motor around, it's doing a million changes a second. Okay, maybe not a million, but it's awful fast. And it may truly be a million times a second. I can't remember how fast. They definitely measure the signal strength in milliseconds, um, I think it's microseconds. And so that's thousands of a second.
Millisecond is thousands.
Or if it's
Yeah.
1 to 2,000. So it's an order of magnitude deeper than that. So you're basically each signal is sent as a packet that's 1/1000th of a second long, which doesn't seem like long, but when you're flying, it may be the difference between you not skimming the ground and flying away, or making it a bullet into the ground, right? A missile
Mm-hmm.
that's a dud, right? All right. So, my point is, if you don't know what happened, like you have the ESC, maybe you blocked off all the airflow to it and it overheated, and maybe that's the actual issue with it. So the ESC might be the correct one, but it may be that somebody changed out the motor. The motor's drawing more electricity through your speed controller, and your speed controller can't handle that much electricity, which means the component is going to burn out, releasing the magic smoke, and now it doesn't work. And kind of understanding how these things work might help you kind of troubleshoot what might have happened. All right. But so when we're looking at an ESC, we look at a motor, and the motor says it tells you at a certain voltage rating, it's likely to draw. There's a big chart, and if you remember, if you looked up some of the links in our last video, you will have, or last show, you'll remember that there's a table that most motor manufacturers have, and they'll have voltage. They'll have the type of prop that's typically on it at that voltage, and then the amount of amperage that's drawn through the motor. And it's important that you note what the maximum amount of amperage that motor will draw, because the battery has energy. The motor pulls that energy through at a certain rate, period. And depending on the kind of propeller that's on it, that's deciding how much work that motor has to do. To do that work, it has to draw a certain amount of current.
Mm-hmm.
You look at that amperage rating, you add 10 or 15%. Most of the time, it's about 10%. So if it's drawing, about 15% is honestly safe. So if it's drawing, let's say, 27 amps, I want to give myself at least a 3 amp buffer. So a 30 amp ESC is appropriate for that motor. So when you're looking to size these things, you want to pay attention to how much energy that motor is likely to draw in the setup that you have on that plane. And then pick your ESC with buffer enough. Again, 15%, sometimes even 20. That way it doesn't heat up and do damage to the components inside the speed controller itself. When you're looking, it's gonna come with an end connector. If most people have XT60s at the size, like a park size plane, which is between, let's say, 30 and 45, or almost 5-foot wings, that tends to be about a park flyer. So most of those are using XT60 connectors, or the yellow ones that are, 3/4 of an inch wide by or so, as opposed to, and that is rated as XT60 is 60 amps. So that means this connector can safely pull 60 amps through the connection. So if you have an 80 amp ESC, an XT60 isn't really your best choice for a connector, because likely your fail point is going to be at the connector. If your speed controllers always have, if it's controlling a brushless motor, it's going to have 3 wires coming out the front. They connect to the 3 phases of the motor. Okay. And if you connect them up in whatever order you think is right, you can do a test run using it with a battery tester, or make sure that the prop is off, but hook it up to kind of your airplane setup and run it with the transmitter, and note what direction it's turning. If it's going the wrong way, you take 2 of the wires and flip them, connect them opposite, and that will change the direction. Remember, you're looking essentially at a triangle. And if you're counting 1, 2, 3, and that's going in a clockwise direction, 1, 2, 3, 1, 2, 3, 1, 2, 3, but you flip the 2, now you're going 1, 3, 2, 1, 3, 2, 1, 3, 2, and all of a sudden it's going the opposite direction, right? Okay. The other thing is, there's typically wires coming out of the other end that's similar to the direction going to the battery. Those 3 go to your receiver. If most quadcopters only need the signal wire to basically have your receiver talk to the speed controller to send the signal you're sending from your throttle to the speed controller so it can control how fast the motor goes and make it match what your the signal you're sending it, right? And that happens through the white wire in that little connector that comes off of the back. The black one is a ground, and so you always kind of have that as part of your system. You want to make sure that your receiver is ground, even if it's not necessarily going to be powered with this wire. The red one, if it has a red one, is that one means it's a battery eliminator circuit, which means you don't need to connect your receiver directly to a battery. You power it off of the ESC. So that's really convenient. It means I don't have to have two batteries in my plane. I don't need one for the receiver and then have a receiver pack just for the receiver and then one for the motor. I can just do it off of the one battery, which makes it pretty convenient, with one exception. If you're flying and you fry your ESC and it is no longer transferring battery power from the battery power through the ESC at all, it burns out somewhere, and it doesn't make it through your battery eliminator circuit, it also means your receiver is not receiving any of the transmissions you're sending, which means nothing. Now you have a dead plane flying through the sky.
Yeah, because you can't even dumb stick it in at that point.
Nope. You have absolutely no control. So that is one of the benefits that people like to have. Some people will buy a separate battery eliminator circuit. They will make a separate connector that basically throughputs the battery, but also has a separate branch for the battery eliminator circuit. So that's connected directly to the battery. And the speed controllers stuff, all you basically pull the little red wire out of the connector and just connect it into the throttle port, because it still needs to receive the throttle signal from your receiver. And a matter of fact, that's part of what we're going to start getting into after we talk about the beeping and all that kind of stuff, is the protocols. Because when I looked at ESCs, I was like, oh, great, I need the 20 amp ESC. It's going to be great. I'm going to pick it out and get it. What's a Simon K? What's a Blelly? What's a Blelly? Why are the numbers after that? What do the numbers mean? What's a D shot? Oh, stink. All right. And that's when I realized maybe I should learn a little bit about how these, what's the deal with these ESCs, and it doesn't really matter to me, right? If you're flying a quadcopter, those numbers are going to be really important. They're going to change. Quadcopters rely on microsecond adjustments to be able to fly smoothly. Planes and free flight craft like that don't need, I mean, it's helpful and it's nice. It just means that your signal gets transmitted quickly, but it's typically not as critical as it is with like a quadcopter. So you'll see in a lot of the quadcopter motors, or quadcopter ESCs, they're typically not going to have a battery eliminator circuit, because the way quadcopters set up, they're powered like through a whole separate system. So the ESCs don't need to send power to the receivers or to the boards or anything like that. So typically all you'll see is the 3 wires going in, and you'll see a 2-wire connector that connects in to the control board. So let's see. So we'll talk about what those protocols mean, but we'll do that in a second. Let's talk about one of the big questions was, what do the beeps mean, right? Because you power this thing up and you go, cool, I got power in there. It goes beep, beep, beep. Did you know how it makes that noise?
I did. And I guess a important thing to note, and we could have done it when I brought up the question, is that the beeps are being generated from the ESC. Like, is the ESC causing? Is happening through the motor, but the ESC is causing. So
right.
The
ESC
that way
is...
somebody doesn't think the motor is what's actually like driving the beeps, or the motor's not what's trying to communicate to you. The ESC's
the bell on the motor. Yeah. The bell on the motor is making the sound, but the ESC is controlling the motor so the bell can make that sound.
Mm-hmm.
Right. Which is pretty wild to me. When I heard that, I was like, what? That makes sense. But I thought for some reason, I'm like, well, there's got to be like maybe a little speaker or something in here, like a little PC speaker
Yeah,
somehow.
a little piezo speaker. Yeah,
Right, right. And I'm sitting
piezo,
there like
piezo, whatever they call them.
piezo. Yeah, I know what you mean. Yeah, it's that little can with a little hole in the top.
Mm-hmm.
Yeah. And then I learned that it was the motor that's actually making the sound, but it's driven through the ESC software, um, and then controlling it through that. So, um, okay.
Yeah,
So we
I
talked.
kind of figured that out when the after hooking mine up and turning it off and turning it on and turning it off and on back on. Yeah, I noticed a pattern because that's back when we had the conversation about I was putting the plane together, hooking everything up with the prop on. Um,
Hmm,
but
hmm,
I was noticing that when I powered everything up, the prop kind of turned a little
twitched.
bit. Yeah,
Yeah.
it twitched, on the front end of that, and then it wouldn't move anymore. But of course, the beeping was happening, and at some point, I reached up and I was like, I bet, I think that's the motor making the noise, and grabbed the motor, and you could feel it vibrate as it was making the noise. So it's
Nice.
cool that it does that.
Yeah, it is pretty cool, and you can even do some cooler things with it from that. But okay, so there's a rating on the ESC. It's typically got a language identifier, so it's like BL Heli, BL Heli S, Simon K. Then it's multi-shot, D-shot. What is that? I think I'm missing one. There's like one more. Let's
One
see.
shot.
One shot,
I read ahead in your
multi-shot.
notes.
That's okay. No, right. And then it's also and then there's also signal protocols, which we'll get into a little bit too. PPM, PWM, and what's the difference? Why do we even care? And ultimately, all of those are talk about the language that the servo receives from the receiver, and how does it use those to create the most efficient reaction to your control inputs, right? That's because
Okay.
that's the big thing is how fast can I get what I've got in my hands to transmit and tell whatever I've got in the air to do what I want. I want that time between when I tell it to do something to when it actually does it in the air to be as small as possible. Because then it's going to be flying as true to as true as I can to just flying it myself up in the cockpit,
Right.
right? Having a big lag time makes it very hard to fly at a certain point. There's probably a very specific number that says once you reach this point, you can just forget about that. I'm not sure what that is, but anyway, okay. So when you powered up, you talked about how when you powered up, it makes these beeps, right? It was doo 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 boop boop boop. And
Sounds
you go
pretty much exactly like mine. Yeah.
exactly right. Yours specifically because you run a 3-cell motor. Um, you have the most typical software stuff on it. I don't even know what the XXD versions are. I know you. I think you've got Emacs. I think they're probably running BL Heli. Um, and so what you have is the beeps. Let's see. The first three tones indicate power, that they have the proper power set up and it's receiving what it should. As it's within the proper range of your power settings for the ESC. Because when you that's the other thing you want to look at when you're buying an ESC, look at the range of power cells. Um, if you're looking for brushed motors, they're typically going to be 1 to 2 cell motors, maybe 3. So the voltage range is going to be really important at what it can take. That's basically saying the components are sized to take up to a certain amount of voltage or as low as a certain amount. Otherwise, they don't function, right? They don't have enough juice to get past the internal resistance in the components. If it's too high, it's too much going through, and then what happens with too much current is it overheats and too much heat, and you end up burning out a component, and now it doesn't work. And they're almost all of these are solid state microchip technology. So it's very well defined what they can and can't take. So be aware. Most ESCs, brushless ESCs, can take between 2 to 4 cells. Some do 2 to 3 cells, And when you get into the quadcopter stuff or you want to go really, really fast, you're going to get stuff that's 2 to 6 cell. Some of them are just 3 to 6 cell. They don't go as low as 2. 7 volts isn't enough to get the components inside to do what you want. Okay.
Hmm.
And some of them can operate even lower than they state, but they're not going to operate well. And they could possibly brown out, which means they don't have enough voltage for a minute, and then they do, then they don't, then they do. And so you can see where you might end up basically having a stuttering plane or a stuttering craft in the air. And while you might be able to bring that down safely, it's not an ideal situation.
Well, let me ask you a question on that then.
Sure.
Because the motor is drawing what power it will through the ESC from the battery. So in the event of a brownout where there's not enough voltage to drive everything that's happening, what typically gets browned out? Do servos brown out while the motor is still running because the motor's going to run, or does motor power fail and servos kind of get priority? Like what's the priority order on that, or can they even program that?
There isn't a program that I know about. So think about it this way: you get a throttle signal from your receiver, so the speed controller opens up, as it were, opens up the throttle to match until the motor tells it I'm there, right? So it's pumping current through. If it's pumping it from the battery, it is so fast, it may not be able to push enough of what's left through to the receiver at the proper voltage. Now, if you're pulling the motor, and so that means the voltage is going to dip. And if you've looked at quadcopter motors, like a race or something like that, you'll see that when they do crazy maneuvers, the voltage on the battery sags temporarily because it's just opening up the floodgates, drawing as much juice, throwing it to the motors as fast as possible. In the meantime, there's not much left to get and power any of the servos or the receiver. Now remember, the servos are pulling power through the bus bar in the receiver, unless you have it set up some other way, because you can. But most planes are set up where all the servos are connected to the receiver. So your power goes into the bus bar via the BEC wire, goes into basically the bus bar. The top one is the signal wire that's what's talking to and from your transmitter through the receiver system. The red and blue are what's powering all of the other stuff. It powers the receiver board and it powers all of the different servos. Each servo, as you're controlling them, is pulling juice. It's a motor just like the one you have on the front of your plane. So you're telling it to get to somewhere. So it's going to open up the floodgates and pull as much current as it can to get there, right? And if all 5 other channels are pulling, let's say, 2 servos a piece, because you have aileron left and right, you have flaps, you have 2 gear things, you have a tail, you have split, horizontal split elevator basically, and you have a servo for each one of them. Now you've got 8 servos, each pulling a half an amp to an amp. Now you're looking at 6 to 7 amps getting pulled through this one little wire, on top of getting almost all of the juice it needs pulled through the ESC. So whatever's left is getting pulled through this little wire, which normally isn't a huge deal except when things are low. Now, all of that juice is going through the bus bar out to the servos. What's left? Almost nothing for the receiver. And now what happens? The receiver doesn't have enough voltage for all the circuitry to work, which means the crystal isn't doing whatever it does, or I'm not exactly sure what happens in the receiver, honestly. One of these days we'll learn about it and we'll tell you about it. But fact is what happens is the receiver loses voltage, the proper voltage to be able to function, which means it stops receiving signal. And it can't tell the throttle and it can't tell all the servos what to do because it can't get that signal anymore because it doesn't have enough juice to do that. So the receiver browns out. So the receiver can't do anything. So now it goes dead.
Okay.
And
when
now
the
there's
receiver
not
goes
enough.
dead, everything's dead.
Well, depends on how you set the failsafe. So the receiver might reset. Failsafe says when power's out, do this. send this signal, whatever it is, whatever the default is that you set. Most of the time, it's nothing. But if you tell it to bank slightly to the left and drop throttle to 20%, it's going to basically do lazy circles. Maybe that's what you want. Problem is I found is that if I disconnect it while I'm working on it and I don't think about it, all of a sudden I've got a plane that's starting to take off. Right? It's all of a sudden throttle goes up to 20%, the rudder turns. I'm like, oh crap. Oh no, don't do that. That's not what I want. Right? In the air, that might be awesome, but while I'm working on a plane, that's not the best choice. So my fail safes are set to 0. Some are just keep it wherever it's at. So if your throttle was at 80% and servos were at a certain position, it just keeps sending that signal. Well, it browns out while it resets.
Into the sunset.
Right, exactly. Which is how that happens. You get out of range, and that's why it keeps going the way it is, because that's what the failsafe is set to. It's not set to return to home or just tank it, man. Let it go in the dirt. And that's, okay. So that's why brownouts happen. At least that's one of the reasons that I understand brownouts happen. You end up having voltage sag because most of the current and most of the juice in the battery is going straight to the motor, the main motor, and all the ancillary stuff is done through a different setup, right? It's going through ESC. The ESC is prioritizing the motor because that's its job. And I don't know of any way to change that. There might be in like the BL Heli suite, like some programming suite that you can do. Anyway, so the first 3 beeps indicate that it's got the proper voltage. The next 2 beeps, the doot, basically indicates that it's receiving the throttle range. So it's got low and high. Got it. Understand what those are. If you have it set to high, it'll go beep, and it won't hit the high one. It's waiting. It's like, when are you going to set why haven't seen the low one yet? The transmitter's telling me what the high is. I haven't seen the low yet. Normally your stick is set to low, right? When you start it.
Right.
Partly because you don't want the thing to start up on its own. But the other one is because you got to set it to low, because the ESC, that's one of the safety things. It's looking for your throttle to be in low condition. So it wants to know, okay, my transmitter's told me high. Am I receiving low? Yes. So it's beep, beep. Okay, got those 2. And then the last ones indicate how many cells you have in your battery. So the range might be within range if my range is 2 to 6 cells, but I'm going to hear beep, 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 beep if I've got a 6-cell battery.
Okay.
Instead of the 3 that you normally hear. And I normally hear 3 because most of my batteries are 3-cell. But sometimes I'll hook in a 2-cell battery and a beep, beep, and that'll be it. And then when it comes to that, it's done. So you can use those things. If it's not making those beeps, it means something different happened than it expected on startup. Maybe your throttle is sent at it's not set at the proper boundaries. So it's detecting a weird throttle, so it's telling you something's not right when it goes doodle doodle doodle, which I've heard before, and most of the time I don't know what that is. And then I've got my throttle set up to high, or the throttle is reversed for some reason. I don't even know why or how that happens, but it gets reversed. So I have it on low, but it's telling the ESC, go full throttle, baby, because it's sending the reverse signal to the ESC. And so it's waiting. Now, a lot of ESCs with like Simon K or even BL Heli, that typically, as I understand it, maybe this is speaking out of turn, but most of that time, if you keep the throttle, if you plug everything in and your throttle is set at full and it stays at full for a couple seconds, you're telling your ESC, I want to reprogram you. I want to change your parameters. And then it'll go, and that's where it might do that sing-songy raise up beep. Do-do-do-do-do-do-do-do. Beep, beep. And it'll be like, okay, so now it's like, we are now in programming mode. I'm ready for special inputs. Which means now you're no longer sending anything to the motor. You don't have to worry about anything accidentally powering up or anything. Now you're in a totally separate, and now you're basically going through your settings in there and changing them. And I'm going to give you an example of settings you can change on most ESCs. but you look at your individual. I can't stress enough. Look at your individual um, ESC manual. Every ESC comes with a manual, or it has one online that you can look up. Like Emacs, I don't think sends one with it, but you can go to the Emacs website and look at their thing. Most of the Emacs things use BL Heli as a default, at least, if not BL Heli S or some other more advanced version, which means if you can plug that into a flight controller, or you plug the flight controller to your computer, there is an app that it will detect what's going on at each of the ESCs. You can reprogram it in the app itself and push those changed settings to each of the ESCs individually. So you can change it on your computer, or even I think probably on your phone if you have the right adapters. I never do, so I just use it as a quadcopter stuff. Um, but there's also programming. A lot of the older stuff, a lot of the more plain 30 amp ESC basic stuff that's like Simon K or whatever, Hobby, King, Banggood stuff. They'll have what's like a programming card, and it's basically a small chipboard with a series of LEDs that once you power the thing up, and this BEC lead is hooked up to the programmer, it literally you're going through and changing those individual modes, those individual things. So let's talk about the kinds of things you can change. Um, you can set your ESC to break. So instead of winding down and letting the propeller just slow down on its own, you can have
Or
it
free
set
spin
to
in the
free
air.
spin. Right. You can set it to stop. And normally, what does that matter, right? A free spinning propeller creates less drag than a braked propeller. Break. Anyway, you know what I mean. One that's stopped in the air. But if you have a folding propeller, like most people do when they have a more advanced, like gliders and things, so what they'll do is they'll use the propeller to get up into the air, and then they'll turn it off. And then what happens is the propellers fold back, and now it's creating less drag, and it's more efficient. So for that kind of application, you want your ESC set to brake, to have the brakes on. You can set the cutoff voltage. It has a default cutoff voltage. I think it's set at like 3.5 or 3.6 or something like that per cell. And what you can do is set it so that you can allow more battery to be drained before it starts going, hey man, I think we're done. We're done. You told us that's it. We're no more, right?
Okay.
You can
Which
set the time. What? Go ahead.
which I guess could do away with the need for the low battery alert chips that we've got.
Maybe I wouldn't trust it. I don't trust it. I'd rather have the battery checker there because I know that, and you can program the battery checker too. You can change that.
Yeah, I found that out one day when I was out flying that you could push
I
that
hope it
little
didn't.
button, and I was like, "Oh, I can
Yeah,
change
oh,
the minimum voltage." Okay.
yeah, you're like, dude, this happens all the time. I still got voltage left. So yeah, you can change that so you don't. If you're like some people hear it and they keep flying for a little while, if they know they're
Mm-hmm.
going to do that, they should set that voltage a little higher than the 3.3, or maybe you don't want to bring your batteries that low. I mean, you want to change that. So that's a way to do that in here. Like I think the cutoff or cutoff threshold and the cutoff type. Like, oh, that's the other thing. Is it a hard cutoff? Is it a soft? What kind of startup are you getting? Is it like a ring and it just wrenches around, or is it softer? So motors with high torque, if you're not looking to spin your plane around because it goes from 0 to full immediately, you can have it slowly ramp up and slowly ramp down. You can change how the throttle adjusts so that it's not torquing your plane or your heli or whatever. Depends on how you want to do that. So there's ways to change that. You can also have a starting tune. We talked about how the ESC creates the beeping noise. It's by vibrating the motor bell.
Mm-hmm.
It can also use that to play songs. Well, it's short, but still play songs. I think
I
we
need to
had a
look into
fellow
that.
podcaster. Yeah. Be careful what you wish for. Remember, every time you start it up, every time you plug in a battery, that song will play in its absolute entirety. Keep it short, is my recommendation. Whatever you have in there, make sure it's short. Because I picked Ode to Joy. I think it was one of the options. Like, oh, that's cool. Da, 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 da. Yeah, well, it goes through the whole 10
Thing before
seconds.
you can
It
do
goes through like
anything.
10 seconds of it. And I'm like, oh, no. It's this ESC. Darn it. And meanwhile, and then people are looking at me like, what's that guy got going on over there? Oh, he's got that stupid ESC again. Yeah. So,
I mean, I just want like the first few seconds of Star Wars Imperial March. Da 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 da, and then we can move
yep.
on.
Yeah. 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 All I recommend, keep it to like a second. You'll be happy. Um, and then there's timing. Timing is something that I'm not really going to get into a lot of, but when you get into, I think we touched on it briefly in the motors. That basically there's an inherent lag between the signal sent and what the motor can do.
Mm-hmm.
Right? There's going to be a gap between those two, and you can adjust the timing to account for that. And there are ways to set that in the ESC. That's all done in the ESC. So it can kind of jump the gun, as it were, and almost send a signal ahead of schedule, knowing that the motor will lag behind, thereby creating a more true to throttle signal performance in the motor. Is it something most park flyers care about? No. But when you're working with high performance aircraft that are doing 3D acrobatics at a show, and you do it as part your living, that might be important.
Mm-hmm.
There's ways to set things back to their default, and then ways to get out. Um, it will tell you what types of battery it can use. That's one of the things when it says the battery. Um, it will beep differently if it's nickel metal hydride. So your more traditional like AAA batteries or AA batteries. When you have a series of those, or even the rechargeables, nickel cadmium and nickel metal hydride, those are a different chemistry, and they have different capabilities as far as how much you can pull from them at once. So lithium ion and lithium polymers react differently. So telling the ESC what battery you're putting into it, it's going to perform differently. It's going to behave differently to be optimal for those battery types. So
Okay,
if you're the kind
that's
that if you're the kind that goes between RC cars and takes their ESC and goes from the cars to the planes to the cars to the planes, and your cars have nickel metal hydride because weight isn't an issue, and your planes you like to keep your lithium ions or lithium polymers, it's important to know how to change that. You were saying something. I'm sorry.
no. I'm good. Go ahead.
Sure. Okay.
Yeah.
All right. I think so. That's the big pieces. I'm just trying to think. Okay. Another thing to concern yourself with the motors, with the ESC. When they come, they rarely come pre-soldered. Oftentimes, they will have a connector for your battery, and they will have 3.5 millimeter, 2 millimeter plugs, or whatever's appropriate for the size ESC you have. And they will have banana plugs to plug into the wires that go to the motor.
So
And
these are
often
plugs that look like bananas. They're curved and all that.
they're actually straight. But I think they're kind of weird and bulgy. I guess like a banana, I'm assuming. Um, and then, of course, the connection to your battery, right? There's different connectors you can choose. Depending on the battery you're likely to put together with this ESC, pick one that makes sense, or just have a bunch of adapters. But either way, you're most likely going to have to solder them on, or they come soldered. Check the solder before you wrap them in shrink wrap. Um, if they're dull and kind of gloppy, they might need to be reflowed with flux and soldering iron so that they kind of work better. So one of the things that's the biggest culprit that I've had and still have sometimes, but it's now that I know how to solder better and have a better equipment, it happens less often. Surprise. Um, when you have a cold solder joint, it creates a temporary gap between the signal that the ESC sends and the motor itself. And when that happens, it desyncs or desynchronizes the motor. So it's no longer going in the smooth 1, 2, 3 pattern, right? It is now off from what it thinks it's telling it. So now the motor is twitching back and forth. When it's doing that, it's likely because there is a gap, and it's oftentimes caused between cold solder joints. Because for
Now,
a moment there, the electricity wasn't flowing like it was supposed to.
now, I'm not catching exactly what you're saying with the cold solder joint, um, but I'm going to assume it's where the wires are cold, but you're putting the hot solder on them. Which, yeah, I
It,
see the funny look.
no. I'm trying to think if that's appropriate. Look, we're going to have a soldering episode, and you're going to lead the way on this one because soldering is probably my biggest failing as a hobbyist so far. That's not true. I failed really big on a lot of ways, but soldering is one that, as I started, I knew nothing about. And while I've improved my capabilities and abilities, what I understand is that the solder isn't flowing entirely. So, yeah, like you said, if the material that you're flowing into, that you're connecting to, isn't hot enough, the solder will not flow into the wires and it will not flow into and around the connector that you're putting it to. And when it doesn't flow properly, it actually creates almost like a bubble, right?
Mm-hmm.
And it creates a cold edge. And that edge doesn't actually transfer electricity because it's
Okay.
probably got flux or some other junk on it, or even maybe an oxidized layer is probably more likely what it is. And that oxidized layer does not transfer electricity properly. So, which means you're
So
not having a complete proper connection electrically between one piece and the next that you solder together.
we can certainly do a soldering episode. I'll have to do a little more research and do some practice soldering myself because I've
Right.
done a good bit of soldering in the past, but just not recently.
Sure.
I know one of the things that I was taught as I was doing soldering or working with it was when you're soldering two material like two wires together, and it's I say this and I recognize that I did not do this when I was trying to repair my wife's headset.
Mm-hmm.
The mic boom like cut the wire, so I was trying to do some tiny little wires.
Oh, those are
Uh,
terrible. Yeah.
Tiny little wires, and
Uh,
my hands
They're
aren't
so hard.
steady enough, and like it anyway. But little tiny wires. But for this purpose, um, sort of what I was taught was you want to heat your wires to the temperature needed to melt that solder and flux. You're not trying to melt. That was a
Right.
trap I was getting into and was
You
having bad connections because I was melting the solder onto the tip and sort of like
mm-hmm.
melting
And
it, let it drip
glumming.
onto the connection. But you need to
Right.
get
But
your wires hot enough to melt the
right.
solder so that the solder flows into them and binds to it.
You got it. That's perfect advice. That's the same thing I understand. Is the soldering gun should be heating the substrate, and the solder that the silver wire
Mm-hmm.
should be touching the material you want to join together. And if it doesn't flow, it's not there yet. It you shouldn't. The only reason why you should put a little bit of the solder on the tip of your iron is to make sure that it's a good clean surface. It's just basically making sure it's clean again. But it
Mm-hmm.
helps with heat flow. Other than that, the solder only goes on the material you're trying to join, not the gun solder gun. For that reason, because if it's not flowing to the material you're heating or to the material you're joining, it's not hot enough, and you still got more time to go. Yeah, you got it. And I probably muddied that up. You explained it perfectly.
Well, we can do a soldering episode sometime, and I will just
Oh yeah,
before we
I'm
do
just
it,
saying
I'll
it's
pull out a bunch of wires and just practice soldering.
right. And with any luck, maybe we can, maybe we can see about getting a manufacturer of a soldering iron, or one of the people from one of these hobby companies that they're in charge of the people who do the soldering. There's plenty of it, um, and they can explain some basics, right? And
Okay.
recommend, hey, as a hobbyist, don't if you don't have a soldering iron, buy one of these 3 ones. You know what I mean? And I know the one I use, I'm happy with. I'm sure you've got one. We can always look to see other good value. I know Josh Bardwell does an episode on that. He's got a couple good recommendations. And same with ESCs. He goes into great detail because he's primarily quadcopter. Now, quadcopters are pretty much the technology that has pushed the speed controller market to push the very boundaries of what they can do. Um, because the faster you can properly change the value of the motor, the more agile and accurate your fast flights are in the racing.
Mm-hmm.
So they're the ones who are pushing a lot of this technology forward. And with that, why don't we talk about protocols? Now, like I said, if you want to really, really, really go deep into the protocols, I'm going to go as best as I feel I can. We're going to put a link to it, but Josh Bardwell has a whole video that covers ESCs, just the basics, and he goes really deep. Again, he's steeped in the quadcopter world, and there's there's a whole like Alice in Wonderland trip. So I'm going to do my best with what I know. When you buy an ESC, it'll oftentimes have a label on it that'll tell you the amazing things it can do. And it'll typically be in the form of like Simon K or BL Heli, BL Heli S. They'll have things shouting on it such as multi-shot or one shot or D-shot or D-shot 600, or it'll be PPM or PWM. It'd be great. And I don't know about you, but I have enough abbreviations in my life. So let's talk about what some of these are, um, and how they're important. And then, um, I think hopefully from that, you can understand the kind of things you need to look for in an ESC when you're selecting one for your craft, your plane, maybe your quadcopter, maybe your helicopter. But we're going to focus primarily on park flyers for the most part here. All right. So I think it's important to understand how an ESC receives signals. And so we're going to talk about receivers and transmitters and how they talk and the kind of information packets they send. And we're going to cover that that's primarily PPM and PWM. And then from that information, we're going to talk about how they were improved through things such as one shot, multi shot, D shot, and D shot with lots of numbers, which were basically an improvement in the communication speed between the transmitter and what the ESC could send to the motor to update its speed. Okay, PPM stands for pulse position modulation. Okay, and that is so both pulse position modulation and PWM, which is pulse width modulation, are both kind of packetized information that send the positions of each of the channels in one packet. Let's say the packet's 1,000 microseconds long. And so each channel has kind of a certain amount of time to send its information out. Okay. So in pulse position modulation, you are basically getting a spike set, and it's arbitrarily a small spike, like a 5 microsecond long or 50 microseconds, whatever is determined by that transmitter and receiver. It basically gets a spike of a like 100% voltage spike at a certain time span in that channel's packet. And depending on where that spike is, that whenever that's received is telling the receiver, set this channel to that value, the percentage along that packet length, right? And then it goes to channel 2, has its next set of packet length. And then wherever the spike is in there is where the value is for that channel. And it continues on throughout all of the channels. And when they're all done, telling you all the channels, there's a gap saying, okay, we're done, there's nothing. And then it'll start again. And it'll continue packet on, packet off, and it'll keep going. And then it'll send a new packet information and then a new packet. So you'll get a new packet every maybe 2 milliseconds, which isn't very long, but it can be long if you're flying at 300 miles an hour or some god-awful speed, or you need to update that information like in a quadcopter where you're using differential speeds of motors to do acrobatic maneuvers at incredibly fast speeds. So that's where you start realizing that maybe the PPM and PWM signaling system isn't quite fast enough. There needed to be a better way. So pulse width modulation is like PPM in that it has that same kind of general packet length. So they both have the same packet speed, where they'll have 1,000 microseconds, and each channel has a portion of that packet, of that full packet length. So let's say we have 10 channels, so each packet will be 100 microseconds. So you have channel 1 will be 100, and so the length that you have in pulse width modulation, so instead of sending a spike at a certain time, it'll basically send a spike that's a certain length of time long. And depending on how long that is, that's going to be, if it takes up the entire packet length, that'll be 100% is going to be the value for that channel. And then this one goes for, let's say the next packet is 25 microseconds. So 25 out of 100, now you're at a 25% for channel 2. And it continues on like that. Now, the difficulty with that is, so what you end up having is, because the PPM or pulse position modulation only sends spikes out, it's using a lot less energy than sending a full spike for a certain amount of time. Let's say it's 100% for all 6 channels. Now, you've got a lot of juice kind of being transmitted, right? Or received. With the pulse position modulation, you're just getting small blips, blip, 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 and then that's it. That tells me exactly what I need to know, depending on where they land. It's awesome. The problem is that for some reason, your transmitter and your receiver are not synced up with that type of system. It is critical that the systems are clocking at the exact same moment. So it's receiving that blip at the same time it thinks it's supposed to be receiving the blip. So the 0 points are set when you hook the two up and you pair them. And when you have your transmitter on, you turn it on in your plane, and then they've got to basically send and receive signals and confirm things. And then they'll kind of give you a beep or something that lets you know, okay, we're synced up. You should be ready to fly now, because now we know we're good. But if for some reason there's ever a signal loss or a gap in that timing, like maybe a brownout or something like that, it may not be able to resync that value. So now those spikes are coming at a different time as far as the transmitter is concerned than what the what the receiver's concerned than what the transmitter was intending. So transmitter's sending it out at 75%, but because the timing's off, it's receiving it early, and it could even receive it in other channels. So you'll end up basically getting erroneous values on your plane. And so instead of doing an up elevator, now it's doing the opposite, or it's not quite going all the way. And it's doing that with all the surfaces, which means now you're in trouble if you're in the air. Pulse width modulation.
Right, and it noses up.
And it knows it's up because it's so
Potentially.
far off. It's in another channel set. Yeah, absolutely.
Okay.
Right. So with the benefit of the pulse width modulation, though it uses more power, it doesn't really matter if it's off a little bit by 10 microseconds or 50 microseconds, because all it's counting is, hey, there's a spike for this long. That's the first one. That's my channel 1. Okay, here's the second one. It's 30. Okay, cool. It's 30. Good. That tells me what I need to know about channel number 2. Oh, the third one's coming in. Here it is. It's this long. So it doesn't really matter how long the gaps are, as long as it's receiving the signal and the width. But it's spaced evenly so that way they all have a chance at being 100%, the full width of that channel, as far as time span is concerned. But either way, both of those send packets out as one set determined amount of time, right? And that's where these other modes are like, well, there's a lot of space in all that, isn't there? Right? Well, with the pulse position, well, why can't I just send all those individual pulses out? Right? Just send them out. Just put them all together. Especially or knock out all the zeros. Anyone that there's nothing, forget it. Just knock them out. Get rid of those. Why spend time waiting to get to the next packet of information? Okay. Why don't we truncate that and put the packets next to each other? The packet 1, once packet 1's done, we got all the information we need. Packet 1 is done. Now we're on packet 2 immediately. Why wait? Right? Who cares? And if you do that, now I'm getting updates more often, and I can keep my servos more true to what I have them, right? So that's where you start getting into these other advances of other protocols, where you get into the one shot and the multi-shot and stuff. And each one of those did another step in reducing the amount of time a packet took to get sent and received by the systems in your plane.
I think I get
it. Me too, I think. Well, hopefully our listeners get it.
Yeah, here's hoping.
We'll have some links to some information to follow up on for sure, especially with the PPM, PWM. Those are the primary ways of speaking. And it's not the protocols that the transmitters and receivers use. That'll be in a different episode. That's a whole different ball of wax. Similar, but different.
Okay. Fair
each
enough.
one of them has a proprietary language that they talk to each other with. And that's different than the signal protocol. So it's important because all of your receivers use PWM signaling protocol to determine where to put the arm, what position to put the arm at.
Mm-hmm.
So your receivers are receiving however they talk, whatever language your transmitter receiver talk in, they talk in that, and they translate that to PWM signals, which your ESCs talk, understand, and your and all your servos understand. It's a lot of language translation, really.
Well, maybe I get a couple more years in this hobby under my belt, and I'll have a far better grasp on it. Because that's a lot to take in.
I hope so. I hope this helped a little bit. Yeah,
it did. I definitely have a stronger grasp on it than I did. And it's a foundation for questions that arise out of this to say, well, let me go Google that, do a little deeper digging.
Mm-hmm. Exactly. And in the show notes, we'll have a couple links for you to do the same if that's something you want to do. Let's talk about what's next in the hobby. What do you want to be doing over the next couple weeks here, Joe?
Well, I would love to get my workbench cleared off. But like I said at the front end, I want to get that glider, the Simple Sword, built up and actually get out and fly. I haven't flown in a while.
Well, maybe we can get together. Maybe I'll come down.
That'd be sweet.
I'll put myself in the bubble, the mobile bubble, and come down. We
talk about one of those big blow up circles.
Yeah, it's like those gerbil balls, Yeah. Well, I'm hoping to get the Viking done. Lately, I've been testing a bunch of rocketry because if I get this going and flying, I've had for a while a desire to put, I'll call it low grade rocketry in some Sidewinder missiles or things like that on a plane, and have an
I think you
electric
were
ignition system.
I think you were showing me that one night when we were talking. You were taking match heads and kind of powdering
Hmm.
them up, and stuffing them
Yep, and
down
that
into
was
a tube.
yeah, that was like a for a tinfoil style size one, and that's great for like a APAC motor or like a small park flyer, 18,
Hmm.
24 inches, something like that. But the Viking is, geez, that's like a 5 footer. So I'm looking like a Big Pen maybe would be a good size for the Sidewinder.
Okay.
So bottle rocket basically, or something along those lines would be pretty awesome. Um,
Definitely have to
and
have some flying space that would approve that.
yeah, yeah, definitely. I've got to look into the regulations for sure. But in the meantime, I'm looking at uh, sugar powered rocket stuff and things like that. Um, just seeing what's possible. I've got a couple of ideas I've been trying out, and as part of that build, um, making custom steerable nose gear has been an adventure in understanding how I might manage that.
Hmm.
Yeah, sorry, steerable and retractable.
Okay.
Yeah,
Well, good luck in
so
that endeavor.
I know, Joe. I'll share with you a couple links, but yeah, thanks. I hope it goes well. So far, I'm pretty confident.
Steerable and retractable. Man, you got two separate servos hooked up side by side. One's got to move
Well,
the other.
you got to think. Okay, so the nose wheel is going to be attached to the rudder servo. So the rudder on the ground, typically the rudder is what does most of your action. Sometimes there is a wheel literally attached to your rudder to
Uh,
steer your plane on the ground. In traditional aircraft, the nose wheel is you steer with the rudders on the ground.
hmm
And
The
so
rudder
what you'll do is
pedals.
what you'll have is the servo that connects to the rudder also sends out an arm that controls out to the nose. So one control arm goes back, one control arm goes forward to the nose wheel. And you also have another servo, a separate servo, that basically is just your retract servo. It connects to the rear wheels and the nose gear, and it basically either coils up and pulls everything in, or it extends out and it pushes everything out. And when it does that, it'll either extend out the gear and bring down the nose gear, or bring it all in.
I feel
So
like for the retract servo and the rudder servo to have that stuff going on, you're going to need probably a bigger servo than been running.
well, I'm using a 9 gram metal gear, and the metal gear doesn't necessarily have a lot more torque, but it'll be less likely to strip and less likely to skip a gear or strip a tooth or something like that.
Hmm.
So if it doesn't work, yeah, I'll probably bring it up another step. Find some low grade, probably car steering servo.
Okay.
Some because they tend to have a lot more torque because they're used to um, basically having a heavy car slamming the steering system left and right. So it's got
All
a
right.
lot of torque there. So I might put like the retracts on the high torque one, and the rudder would probably be fine either
They
way.
have to see if they have to see if there's a way to slow that servo down because if it's a steering servo, they tend to. I'd imagine they change position fairly quick.
They can, and some of the modern transmitters have a way to set the speed at which it moves, right?
Okay.
Um, and there's also a circuitry that you can put in between, like your in and your out. And what it does is it's a variable resistance, and then based on the resistance or how you turn the resistance, it'll increase or decrease the amount of speed the signal goes through, basically. So it'll effectively slow down the signal to the servo.
Okay.
And so it'll slow down. I bought one or two of those the one time because I might be able to use these. So maybe this is the project. We'll see. I'd rather do it through our transmitter because then I know how to do it for every plane.
That's right.
Oh my God.
All right. So
it's ridiculous. They have Toto's Africa being played on an ESC. Just saying. So maybe what you want is possible.
Yeah. I mean, speaking of Toto Africa, I saw a video come across my Facebook feed of 2 Tesla coils that were playing Toto Africa. That was something. Makes me want to build Tesla coils.
Oh my God. Yeah. Oh, you know what? I've got one of those. Hold on. I'm going to show you. I'm going to share with you the link for the mechanism here. But I think that pretty much covers it. What are you planning to do? You're gonna fly your plane, or you're gonna make a plane to fly. That's your goal.
Hopefully soon. Yeah.
Okay, that's right. Good.
Continue working on this bedroom renovation build, and just work's got me busy right now.
That's a good thing, isn't it?
It is. I'm happy with it. Like I'm not complaining. Been very, very fortunate, very blessed that throughout all this, still get to work. So
yeah, absolutely right. Good.
Right, so what are we talking about next time?
Nothing. I'm just kidding. Well, it depends on what we're gonna do. We're gonna try to tackle batteries.
Okay.
I think is the goal. We've had a request by a listener or two who've said that, and I tend to agree that batteries are, again, one of the other major pieces of your powertrain, right? We talked about motors, we talked about ESCs, so it's pretty reasonable that the next logical step is your batteries. And they need special care, and for the safety of you and your home, to make sure your lipos don't accidentally catch fire because you mistreated them. The modern batteries we use today pack a great deal of power in a very small space, high power density. So if they get misused, it is possible that they will have a chemical reaction that ends up basically setting fire to things around it. So it's important to make sure that you treat them right, store them right, and that you have a safe way to store them and charge them. So we'll talk about all that stuff as best we can. And so until then, go outside and fly something. No, what really, Joe? Go fly something.
I'm trying.
You will.
Soon.
You will. I think I actually have that buddy box system set up. So if I come, I might be able to come down and we'll buddy box.
I'm curious to see if our 2 boxes can buddy up because they're 2 different brands.
So, as I understand the one system, I'm using the buddy box system I have set up is through my 2 jumpers. I have a jumper T8 SG and the T16. But the way the T16 does it is it basically, I should be able to put it to your X9, and as long as it sends out a PPM signal out of head jack, or even the one in the back, it'll basically take that signal, and all it's doing is shunting your controls through my transmitter and transmitting it out my transmitter in the connected way.
Right.
And all I'm doing is basically flipping a switch that passes the controls through you. So you have control until I flip a switch, then I've got the control. It basically disconnects the pass through. And then I'm doing the stuff. Otherwise, it passes it through you, and then basically your sticks do the things they're supposed to do on mine. Okay. It seems pretty straightforward. Yeah, me too. I'm hoping to be able to try that this weekend. So maybe next time we get a chance to talk and get a chance to talk to our listeners, they'll get to hear my experience with the buddy box. With any luck, it's good, and then we'll get together.
All right. Well, we'll go ahead and call it here. And
awesome.
Thank you everybody for tuning in and listening. And,
appreciate it.
Feel free to feel free to write in, ask us questions, leave feedback. We'd love to hear from you. And until next time, have fun.
You too.